Just going to start up here or what? Not starting. All right, here we go. Circumference. Here we go. Let's hear from 10. Circumference formula. There we go. Pi d or 2 pi r. Make sure we know at least one of them coming into tomorrow. Next, I have the circle up here, circle O. Angle AOB. I want either the name of angle AOB, what type of angle it is, or how do you find it? I don't care. Give me one though. Okay? Give me one if your number's called here. How do I find it? And what's the name of the angle? 12, either one.
Is it an interior angle?
There's a lot of interior angles. Need more than that. Need more than that one. 17. 26. We don't have one. Yes? Oh, hi, Jack. Sorry. We could stare at each other. I'm doing well. Yep. Okay. I need either the name of the angle in the circle or how to find it. Central angle. How do I know? Where's the vertex? Center of the circle. How do you find it? How do I find it? Angle AOB is the same as what? 12. Angle AOB. How do I find this angle? This angle will be the same as arc. Which one? Name the arc. AB. Everybody good there? We're all good. All right, moving on. That's only 2 facts right there. Length of an arc tomorrow. You're going to know one. You're going to know both. It's up to you. All right, up to you. I'm not going to ask that because you can simply just read over there. Angles in degrees. Arc length is going to be the measure of the arc over 360 times pi d if your angle is in degrees. If it's in radians, that's the other formula, S equals theta r. What's the S stand for? Here we go. 5. What's the S stand for? Arc length. What's theta stand for? 17. What's theta stand for? You're right. Angle measure, but it's got to be in radians. And then r, radius length. Are you going to know both? If you only, hey, let's say you just decide to memorize this one. And the angle's in degrees. What do you have to have the ability to do? Speaking of converting, how do you convert? Degrees to radians. Hey, I get it. It's on the formula sheet. But there's 2 of them. You got to know which one to pick. All right, so it's a little tougher than just saying it's on the formula sheet, which I'll give you tomorrow. Degrees to radians, multiply by, here we go, 9, multiply by pi over 180. If it's in degrees, then you got to go to radians, and I won't ask anybody for the next one because you simply flip it, multiply by 180 over pi. All right, both will be on there tomorrow. I will give you a formula sheet. And then on Friday, we reintroduce law of sines and law of cosines. You may need it. I'm going to guess you're going to need one of them tomorrow on one of the questions. Law of sines. What's it say? Law of sines going into tomorrow. 20, what's law of sines say? Oh, that's the next one. That's cosines you're starting off with. Sines is the ratio. Go ahead. Okay, hold on. Quick question. What does A represent? A lowercase a. It's a side length. In the triangle, it's a side length across from the sine of the angle across from it. And then go ahead, finish. And again, b, lowercase b is a side length. Sine of b is the angle across. Law of cosines. Law of cosines. 4, law of cosines. Okay, it's in your packet from Friday. Let's go. What's a squared? What do I always plug in there?
With the base of the triangle. Yeah, I remember.
How many sides in a triangle, Paul? 3 sides, right? 1, 2, 3. How do I know which one to plug in? I'm always going to give you an angle. Whatever's across from that angle, that's what gets plugged in for A. We good for that for tomorrow? Everyone else, good. B and C are the other 2 sides. Probably going to have to use one of the other formulas tomorrow. I'm just letting you know that's your call what you want to do with it. All right, I'm still not done. Let's roll. A diameter perpendicular to a chord. Finish that statement. If I have a diameter perpendicular to a chord, finish that statement. Finish that statement. 3, a diameter perpendicular to a chord, bisects the chord. Yep. And finally, if I have 2 chords that are equidistant from the center, so the same distance away from the center, what do I finish that statement? 22, finish that statement. Yep, chords are congruent. All right, anything now? All right, little wake-up call to start class off today. No proof on there tomorrow. I couldn't see putting a proof on. There's not much you can do with the proofs at this stage in the unit. So no proofs on there tomorrow. All right, this is what you can expect on there tomorrow. What we do today in class, not on there. Homework will be checked tomorrow, but I did not put any of the topics from today on there. Anything you want to ask? We just went through a lot right there. A lot of formulas, a lot of facts. One reference sheet. Okay, I am going to go to Thursday night's homework first, which was out of the book. And just so you know, I'm talking about 8 through 18 even on page 719. 8 through 18 even. I didn't think it was that bad. I selected number 8 to have a couple people do with me here. All right, so this is number 8. I didn't have you guys get textbooks. I didn't think they were needed. So here's number 8. I want to know how you guys went about finding X right now. How'd you guys find X? All right. Okay. 2. I got one first question for you. What are HJ and FG in the circle? What do I call those? HJ and FG. Chords. And what did I mark about them? They are congruent. You have a theorem. If the chords are congruent, so are the blank. 17. If the chords are congruent, so are the arc measures. This is 70. Name another arc that's going to be 70. HJ, calm it down. 70 degrees. Not done. Hopefully you're paying attention earlier. 9. What type of angle is X? Central. How do I find a central? 5. How do I find a central angle? Any central angle. How do I find its measure? It's always equal to what? Any central angle. Let's go back to it. Any central angle is equal to what? Measure of the arc. Let's go back to this one. What's the measure of its arc? Okay. Everyone all right? How we got there? That was two facts. Anything else you want to go? Yep. 14. Let's see if I still got it up here. Okay, 14, the circles are congruent. All right, ready? How many total degrees in a circle? 360. That's 155, right? I can find that part, right? That's really the part I'm not concerned about, but this is 205, right? So 360 minus 205 will give you 155 for their. So ready? This is 155 because they both total up to 360. You're good right there. What do I know about these two arcs now? I have a theorem. If the arcs are congruent, so are the, what are these? Chords. So if arcs are congruent, so are the chords. Good? Okay. Yes.
If it's an arc length, then how can it be in degrees?
Who said it was an arc length?
Well, just generally in the vocabulary, like in the last question, it was 70 degrees was an arc length.
No, length can't be in degrees.
Yeah, that's what I said. So why is it that the arc is considered 70 degrees?
Because it's out of 360. It's 70 degrees out of 360. There's two ways to express an arc, in the measure out of 360 and then actual length of it. Okay? So when it's in degrees, that's the part of it that's out of 360. All right? Other questions from that homework? All right, and then we got a little bit tougher, some proofs, huh, on Friday? Welcome back. You guys had this algebra problem. There was only one algebra problem, and I'm going to see how you guys ended up doing it. Ready? All right, let's start. 21. I have this is 86 degrees. Where can I put 86 again? Name that. Thank you. Central angle. Just want you to get talking the vocabulary. That's 86. 13. Can you find the angle next to it? We have a 13. How do I find the angle next to it? They're supplementary. 1 minus e. That's 94. Not bad. Let's keep this rolling. 21. What is this part of the circle called right here? Radius. What did I already label another radius here? X. So that one will also be same measure. 14. What type of triangle am I working with? Isosceles. What do you know about the angles across from these sides, Caleb? They're congruent as well. So I believe, let's see, what does that come out to be? 43? My math's correct? 48? Yeah. 43? Yep.
You asked us to find mistakes.
Mhm.
I found many.
Oh, did you?
Yes. Would you like me to go through?
Well, why don't you hold on there? Okay. There was a mistake in my proof. That's what I was referring to.
Yeah, and I found that one,
Yeah.
but I found more.
Oh, all right. Well, we'll talk, and I'll probably deny you, but it's okay. Okay. So going back to this one to finish this up. Sines and cosines. All right. Sines and cosines. Probably would use law of sines in this case. Here's why. Give me a side length, you know. 20, what's it across from? Sine of 94, give me another side. X, it's across from sine of 43, and we can cross multiply from there. Okay? You are going to have something similar to this tomorrow. All right, where law of sines or cosines needs to be used. The fifth. Oh, 48, huh?
Yep, that was my first one. My second one was. So it said that segments are congruent right after saying it was a bisector, so it like
Yeah.
skipped a step.
That's what I was referring to here. Is right here.
Yes.
I cannot say that EW is congruent to WF by this theorem. All right, take a look, everyone. If you're going to use this theorem on the second proof I'm on right now, the second proof, this theorem can only be used to say a diameter and a chord bisect each other. So you tell me, what should I have had here in step 2? I should have had AC bisects EF. That's what I should have had in statement 2. EF, AC bisects EF, and then step 2.5, 3, then I can say EW is congruent to WF by definition of a bisector. Yeah.
So the reason for AC bisects EF, what's the reason for that?
Say that again?
Like, what would be in the reasons column for when you say AC bisects EF?
Diameter perpendicular to a chord bisects the chord. And then definition of a bisector, the two pieces are equal. That was it?
One more
Oh, yeah, I'm sure. Ready, go ahead.
You spelled R like ARE as AR. I think it was on the other page.
Where are we?
There. R congruent. AR, not ARE.
That's an R. I just write quick and sloppy. Hey, that's ARE.
Where's the E?
Right, there's the R. And then there's the E.
That just looks like AR.
I see the it's a lowercase r.
I'm not accepting that. That one's fine.
It's the same thing.
No, it's not.
Yeah, that looks like four, cursive.
All right. Was there anything on the two proofs? I know that I didn't put a proof on there tomorrow, but we are all good on the proofs. Okay. Here's what I need then. I need the packet out. I actually just want to see the proofs because I just went over the algebra one. So show me the proofs and the bookwork, the 8 through, what was it, 8 through 20? 18, even. In all seriousness, any questions for tomorrow's quiz? Because what we start right now, I didn't put on there. It will be checked tomorrow, though, first thing. I'll go over questions, and then we'll take the quiz. But anything we've gone over here you want to ask? Got a lot of facts, a lot of theorems, I know. And this is only a third of the way through. All right, then. I've been real picky, and I'm sure you've gotten annoyed about you just can't say the word angle. You need to attach central angle with it. And here is why. There is more angles inside a circle other than a central angle. That's where we're going today, called an inscribed. Where was the central angle, by the way? Where's the vertex of a central angle? It's the center of the circle. Inscribed, it's actually on the circle. So here's what I want you to do on the first circle to the left. Put a point somewhere on the circle. And the two rays I want as chords. All right, the two rays I want as chords. And let's just label it ABC. That is not a central angle anymore because the vertex is not on the center. We call this an inscribed. See the difference? An inscribed angle. The second circle, I want you to put a diameter in. Draw in a diameter for me. Because I also want you to remember that a diameter is a chord. And you could also have an inscribed angle with one side as the diameter. We see the difference between central versus inscribed. We all right? Central versus inscribed. How'd you find a central angle, by the way? I think we've went over this twice today. How do you find the measure of a central angle? 16. How do I find a measure of a central angle? Let's measure the arc. Not the case here. Not the case here. Inscribed angle. It's pretty close, but not exact. Anybody want to take a guess? It's not equal to the arc. Half its arc measure. Half its arc measure. You tell me now, what's angle B equal to on my diagram? Angle B would be equal to, and I'm not looking for an actual measure, but how would you find it? 6.
Half of arc AC.
Half of arc AC. And then how would I find the measure of angle E here? That inscribed angle. Let's hear from 6 again.
Half of arc FD.
FD.
Sorry, I don't think that was English.
Okay. Okay. Even though some of your words may have run into each other, I understood it. Kind of like letters running into each other. Yes. Yep. Okay. All right, let's roll. Triangle ABC, inscribed. All the vertices, yep. Arc AC, we got it. Perfect. Find arc BC. Arc BC. This arc measure, not the length, the measure in degrees of BC. Do you see an inscribed angle that's drawn to arc BC? Do we see that? Everyone see angle A, 80 degrees drawn to BC. So do I just take half of 80 and I'm good? No. What's the rule? The angle is equal to half of the arc. All right, the inscribed angle is equal to half of the arc. So you tell me what should be done here instead. Here you go. 1, Maddie. Go in reverse, double it. So it's going to be 80 times 2. So that arc measure, 160. Everyone see that? The angle is half the arc. Angle B. Angle B, definitely inscribed. It's on the circle. It's inscribed. So how do you find it? 1, Maddie, again. What? Okay, ready? Angle B. Go slowly, just a little slower here, Matt. What arc is it drawn to? Which is how many degrees? So you took half of 88 in this case, and we end up with an angle of 44 degrees. Yep, for angle B. Everyone all good? What about angle C? It's drawn to an arc I do not know. But you don't need circle facts all the time. You don't need circle facts. What's a clean, easy way to find angle C? Oh, 29.
You just add you subtract 88 before.
What? I thought this was going to be pretty clean. Angle C. The remaining angle in a triangle that I do not know.
So you Add 80 and 44 and subtract it.
From?
180.
Okay, there I go. Yes. Can you please do that to redeem yourself?
56.
All right, there we go. And there's multiple ways of finding the remaining arc AB. I want to know how you want to do it. Fill us in. 9, fill us in. How do you want to find arc AB? There's one way. I could do 360 minus the other two arcs. Or I could do what to 56? Double it. Okay, and what do you got there, Remy? $112. Perfect. Anything there? Finding an inscribed angle on your own. Oh, shocker. We're going to have some more facts here. Arc A. Here we go. Arc A. And just so you know, arc A is PT. All right, just so you know, arc A, that's the same as arc PT there. Do you see an angle that is drawn to arc PT? Does anybody see an angle? And there's a lot of them in there. Come on, find it. Find an angle that's drawn to arc PT. What's the angle, Mason?
Angle
PQT. Everyone see that angle. What type of angle is it? Central or inscribed? It's inscribed. That's an inscribed angle. So you tell me what I can do with the 60 to get to arc PT. I got 60s inscribed. What can I do with it to get to PT? You got it. 29. Here we go. Oh, boy. What's the rule? Ready? What's the rule between inscribed and its arc? What do I have to do to the arc? Okay, but now I'm going to the arc. How'd you? Whoa, easy hot shot. All of a sudden, just getting the answer here. How'd you get that? There you go. 60 by 2, you get 120. Woo, this guy. And then what about angle B now? Angle B. One, Matt, ready? What type of angle is angle B? Inscribed. So we're going to take half of an arc here. Can you tell me what arc it's drawn to? Name the arc with letters that angle B is drawn to. Whoa, whoa, I don't think Q's involved. Here, ready? Here's angle B. Name the arc it's drawn to. What's arc is in between them? PTS, right? Everyone agree? How large is PTS? 14. What's the measure of PTS? 150. So everyone see why we're taking a half of 150, not 120, not 30. And Caleb, just finish that for me. You got 75. Darn right you did. 75 degrees. Questions before I get to this blank box that something obviously needs to fill in with. Draw yourself a circle in the box. In the box, draw yourself a circle. Put a center in there. You don't have to label it, doesn't matter. Okay, I'm going to draw an inscribed angle in right now. I'm going to call it AEC. And I'm going to draw a second inscribed angle in. Ready? And I'm going to call that angle ADC. And they'll intersect at point B. You and your group, I'm going to give you 30 seconds. Find a pair of angles, please, that are congruent. No, I'm going to challenge you. Find 2 pairs that are congruent. Find, maybe 3 pairs that are congruent. And why? All three pairs are, yes, but which pairs are congruent? That's what I want to know.
Yeah, that's what you come up with.
Okay, let's go around the room here. 9, name a pair, one pair. ABC. Got it. These two right here. That was one I did not expect right off the bat. I expected people to say the vertical angles, which are true. Okay, let's discuss, because this is going to be the theorem I'm going to write in. What type of angle is angle E? What type of angle is angle E? Inscribed. Name the arc it's drawn to. AC. What type of angle is angle D? Inscribed. Also drawn to which angle? Which arc? AC. So aren't for both E and D, you're going to take half of which arc? The same arc. Everyone agrees? So here's why they're congruent. Here's what we're going to start writing in the reasons column of your proof. 2, what type of angles are they? 2 inscribed angles. Where are they drawn to? Okay, 2 inscribed angles drawn to the same arc. And what'd you just find out about them? Are congruent. Just want to make sure that's not arc versus R. All right. We see that working there. So if you have 2 inscribed angles, they're drawn to the same arc. Same thing here. Everyone, hey, last thing, take a look at A and C. What type of angles are they? Inscribed, and they're both drawn to which arc? 21. A and C are both drawn to which arc? Hold on. Angle A and angle C are both drawn to the same arc. Name the arc. ED. So they're congruent as well. Okay? Questions? All right, one more, couple more facts here. Actually, you know what? I'm going to let you guys go on your own here in your group, because we need some practice on our own here. Find X and Y. You're finding 3 things here. You're finding angle X, you're finding angle Y, and then you're finding the measure of arc BC. And AB is a diameter. Okay, so in your group, angle X, angle Y, and angle arc BC. All right, here we go. Let's get this moving. 15, here we go. What type of angle is x, first of all? Number 15, what type of angle is x? It's inscribed. So I go half its arc. And if you take a look, follow it. Half its arc is also, what do I call that type of arc going into tomorrow's quiz? From A to B, what do I call this? It's not a major, it's not a minor. It's a semicircle, which measures how many degrees? 180. So you're taking half of 180. That's a what type of angle right there? That's a right angle, 90 degrees, because you're taking half of 180, a semicircle. All good? All right, now how can I find angle y? 6. How'd you find angle y?
Just subtract 88 and 90 from 180.
Yep. You didn't need any circle facts. You had 2 out of the 3 angles in a triangle, so 180 minus 90 minus 58. What did that end up giving you? 32 degrees. And the last thing I'm going to ask is for the measure of arc BC. The measure of arc BC now. 15, do you see an inscribed angle that's drawn to BC? Y. What did we find out Y was? It's 32. So I don't want to take half of it. If I'm going to find the arc, I want to double it. And we end up with 64 degrees. Not done. I got one more problem there on the next page. We okay with all that? Ask away, anything. How we got any of those values? Yes? How did we get x? Okay, x was an inscribed angle, right? So it's half of something. Half of this arc, because that's where it's drawn to. It told you in the directions this was a diameter. So this would have been a semicircle, 180 degrees. We good? Any others? Last one. GFE. Guys, follow the directions of the vertices for me. G to F to E. Follow the directions of the vertices. G to F to E. Anybody see an angle that's drawn to GFE? Anybody see an angle that's drawn to GFE? What's the angle measure? 86, and it's inscribed. So what do you want to do with that 86? 17, what do you want to do with that 86? Multiply it by 2. Go ahead. 86 times 2. What do you got back there? 172. Nice job. And here's the last fact for today about the inscribed angles. Angle F. Angle F. Please go back on the previous page for me. Go back on the previous page. See what it says about a quadrilateral. If you have a quadrilateral inscribed, what do you notice about the opposite angles according to the theorem? Supplementary. So what can I do to find angle F? 28. Nope. 29. What can I do to find angle F if they're supplementary? Yep. Go ahead, and I end up with 94 degrees. The more I think about this, I'll have this due on Wednesday, this homework, because I think you guys have enough to think about for tomorrow's quiz. All right, so I'm not going to check this until Wednesday.